Alright, so we have the equation x prime plus 8x equals 0 with an initial condition x of 0 equals 4, and we're asked to solve this differential equation. So the first step to get this into a form we can recognize is to get the x prime isolated on its own. So we can write the x prime is equal to negative 8x. And now this is an equation that you should recognize. We looked at this one in class, and we said that its general solution is x of t equals some constant times e to the negative 8t. So again, this isn't something I've shown you how to find the solution to yet, but you should just recognize that if the equation has this form, the solution will look like this. Now the last step is to use our initial condition. X of 0 equals 4 implies that 4 is equal to c e to the 0, and this means c is equal to 4. So our solution is 4e to the negative 8t. Okay. The second part of this problem gives us a different equation. X prime equals cosine of 3t plus 2 with x of negative pi over 3 being equal to 1. Okay, so this is our differential equation. Notice that unlike the first equation we had here in this one, x is only appearing in one place in this derivative. Everything on the right hand side is only a function of t. When you have differential equations like this, you can solve them just by taking the antiderivative of both sides. So in this case, we get that x is equal to the antiderivative cosine 3t plus 2. So the antiderivative of cosine is going to be sine, but notice that when we take the derivative of this by the chain rule, we'll get a 3 coming out front. In order to cancel that 3 out, you have to put a 1/3 in front of the sign. 2 you can think of as 2 times x to the power 0, so by the anti-power rule, that will turn into 2t. And then, of course, we have our usual plus c. So now, x of negative pi over 3 equals 1. This implies that 1 is equal to 1/3 sine of 3 times pi over 3 with a minus sign, minus 2 pi over 3 plus c. If we simplify, you'll see that this is sine of negative pi, but sine of pi or negative pi is 0. Then we have a negative 2 pi over 3 plus c, and this tells us that c must be equal to 1 plus 2 pi over 3, or 5 pi over 3. So that means that our general solution, or our solution to the initial value problem, is 1/3 sine of 3t plus 2t plus 5 pi divided by 3. Okay, so now the last problem is x prime equals 1 divided by 1 plus 4t squared with x of 0 equals 4. Okay, I didn't notice this, but apparently that was an initial condition I was fond of when I wrote this problem. It appeared in both A and C. At any rate, so we want to find the antiderivative of this function. So the thing to notice here is that if we just had 1 divided by 1 plus t squared, that's a common antiderivative you should recognize. It turns out to be arctangent. So if we put this 4 here, then we end up getting 1/2 arctan of 2t, because 2t squared is what gives us the 4t squared. 2t all squared is what gives us the 4t squared here. And when we take the derivative of arctan by the chain rule, this 2 will come out, so that's why I put the 1/2 out front. And then we have a plus c as usual. So now x of 0 equals 4. This tells us that 1/2 arctan of 0 plus c is equal to 4. But arctan of 0 is equal to 0. And so because of that, we just get that c is equal to 4. And our solution is 1/2 arctan of 2t plus 4.